Hi friends, welcome to today's video. So today we are going to discuss dispatch semaphore. So in the last video we discussed about the race condition and how we can handle this race condition using dispatch barrier. So this dispatch semaphore is also used to handle the race condition. Now I'll just give you a little brief about the race condition. If you want to read in more details, please watch my previous video. I'll just give the link in the description. Now let's take a general example of race condition is that you have a bank account and then you are trying to withdraw the money from the bank account from two different sources. Let's say that I'm using my mobile banking and I'm using net banking at the same time. And let's say that your account balance is 10k and you are trying to withdraw 10k from the mobile also and 10k from the your wave also. Now what will happen that either one of that will get success, right? Because you cannot withdraw 10k from both at the same time because your account balance is just 10,000. So that in that case, what is happening that both the process is trying to access the same resource, and what is that resource? That resource is your account balance. Okay. So now let's take a example that I have written here is the same example that I did it in my previous video and solved it using dispatch barrier. So here the scenario is that I have a 5 ticket and then here 4 person are trying to buy that ticket. So Nilesh, Ramesh, Mahesh and Somesh. And if you see that Nilesh is buying 3, Ramesh 2, Mahesh 4 and Somesh 2. Now here there is a for loop that I have taken buy ticket which is getting called from I think the view. So this is calling your buy ticket on the on appear method. Now the moment the buy ticket is called, so I'm looping inside my for loop that how many tickets I have to buy, and then I'm using this concurrent queue to buy the ticket asynchronous call, and then I'm calling this book ticket. And here what is happening, I'm just sleeping this for 1 second so that I can see some differences, and I'm just for the log I'm printing when the book ticket method actually started. And if the available ticket is greater than, means if still I have the available ticket and I'm booking it and printing that ticket is successful, else it will print ticket is unsuccessful. I also have one more method which I have just taken after my this call, so that I can just show you that this method is not blocking my main thread. After this do something else is also getting called. Okay, so let's run this sample and see what happens without handling the race condition. So first, ideally what should happen, Nilesh and Ramesh should get success because 3 and 2 that equals to 5, and Mahesh and Somesh ticket should fail actually, right? Now if you see here, the ticket booking started for Mahesh and Somesh, then it started for Ramesh and Nilesh. In between it also called this that I am doing what I want. Okay, that means it's not blocking. And if you see that the ticket is unsuccessful for Mahesh and unsuccessful for Nilesh. So these two, Nilesh and Mahesh, is unsuccessful, and Ramesh and Somesh is successful because it doesn't follow any of the sequence because it was happening asynchronously. But till now, one thing is that the result was good because the successful was only for Ramesh and Somesh, and Ramesh and Somesh wanted 2 and 2 4 ticket, which is still correct. But if you run it one more time, what you will see again, every time you run, you will have a different output because you don't know which thread will pick first. Because if you see in this case, this happened first and then the ticket booking started, and this time it is successful for Nilesh and Somesh and unsuccessful Ramesh and Mahesh. Okay. Now Somesh wants how many ticket? 2. Nilesh wants 3. The result is still this is not breaking, but the sequence is not guaranteed. Let me try one more time because I just wanted to show that it can break the desired result also. Now this time if you see, it got successful for Nilesh, Ramesh and Somesh, and Nilesh 3, Ramesh 2 and Somesh 2, that means 7 ticket booked and you had just 5 ticket. Now this is what is happening due to the race condition because all this asynchronous block is trying to access this available ticket, and that's why it is giving you some unwanted result. Okay, now let's see how we can solve it using dispatch semaphore. Okay, now if you see what is dispatch semaphore, so here This is an object that controls to a resource across multiple execution context through use of traditional counting semaphore. So if you see that behind the works how this dispatch semaphore works, so there is a counter in dispatch semaphore. If you see, when you initialize this semaphore, you have to pass a value, creates new counting semaphore with an initial value. Okay, so basically this tells that how many thread it can access simultaneously. Like in the last video, we saw that we can handle the race condition using barrier. But what the barrier was doing, that it was just allowing one thread to be executed once, and once that thread was completed, then only it was giving the next thread into the picture. But here in the case of semaphore, it's not like that. We can just have one. If you want to execute 5 threads parallelly, you can even do that. You just need to pass the value here as 5. But that's a very like impractical scenario. In most scenario, you just want like you are not trying to handle the race condition. You want just one thread to be executed at one time. So we'll be passing this value as 1. Okay. Now the semaphore basically works on a FIFO. Like it basically behind the scenes create a queue, thread queue, and how many process let's say you are putting. In this case, we are going to put 1, 2, 3, 4. So it is going to create 4 thread. You can say 4 thread pools. Okay, and these will be accessed in first out phase. Okay, now if you see here, we have signal and wait, and then we also have timeout. Let's say that generally what we do, once you start any function, you just call this method wait. Now, and once that execution is completed, you call the function signal. Now let's say that you are waiting for your function to be completed, and that function is not giving you any timeout or any kind of response. In that case, what will happen? It might reach to a deadlock scenario, right? So in those cases, you can even use with timeout to avoid any sort of deadlock. It's not like that you are trying to solve a problem of race condition and you end up having a problem of deadlock. So for such scenario, even you can use for timeout. Okay, now let's first understand what this wait does. Okay, so when the semaphore receives a request, it checks if its counter is above 0. If it is above 0, then only it will allow that thread to be executed. Okay, now if it is, then what the semaphore does, this when you call this wait, the semaphore decrements it and give the thread, you can say that a green signal that okay, you can go and execute this operation. Otherwise it will simply push that thread at the end of the queue. So let's say that in this example, you are going to push how many operation? 4. Okay, so all the 4 operation will come in the queue, but how these are going to be executed? These are going to be executed one after the other. So for the first time, the first thread will come. Once that will execute it, then only the next, and then next, like that it will happen. Okay. Now the next method here, which we are going to use is signal, and what it does, it increments the semaphore. Okay, so wait will decrease and signal will increase the value. Okay, now once the semaphore receives this signal, so what it will do, it checks if the FIFO queue, that the thread queue that it has created, has thread in it. Okay, if it has the thread, then the semaphore will take the first thread and give the green signal that now you go and execute. Okay, otherwise it will just increment it counter. Okay, so that's how behind the scene this will work. Okay, now let's come and see this at the code level. So here what I'm going to do, I'm going to create a semaphore object. So let's say that let semaphore equals to dispatch semaphore, and see here we have to pass a value, and I want that at one point of time only one thread should get executed, so that's why I'm giving the value as 1. So don't confuse that what value you need to pass here. Let's say that in your scenario you want 2 thread to be executed, you can give even 2. Okay, so that all depends on you. In most of the cases you will be passing just 1 when you are trying to solve the race condition. Now as we saw, what we have to do, we have to just call, once this method is started, I'll call semaphore dot wait. That means I'm telling that, see, and here also we have wait with timeout. I'm not going to use this because it just sleep for 1 second. Definitely it's going to be completed. Okay, so semaphore dot wait, and what it will does, just now you saw that wait will decrease the, what it does, the wait will decrement the semaphore. So that means the moment it calls, what was the value? The value was 1, so this will become 0. Okay, and again we have another method here. Once this whole operation is completed, I will call semaphore dot signal, and what it will does, it will increase the value. Okay, now let's say that when you run this code, all this 4 operation, as we are calling in asynchronous block, all this will come one by one. Okay, so first Nilesh will come, then Ramesh, then Mahesh, then Somesh. So how this will basically happen? So the moment the Nilesh will come, the semaphore value is 1, so the wait will make it 0. Okay, and now before this operation finishes, meanwhile the next operation will come, because obviously it will happen as it is going asynchronously. It will not wait for this to be completed, right? So the next will come, but what the semaphore value will be at that point, the counter value will be 0. Okay, so it will wait in the queue, it will not start the execution. Okay, and once this operation is completed, it will, the signal will again increase the value. That means your counter will again become 1, and then the Ramesh will start executing, and then Mahesh, then Sumesh, like that all will execute one by one, and that will happen in synchronous order. Okay, so now let's run this code. So if you see, when we run this code, it is giving me one warning, and the what warning, if you see this, it's telling that thread running at user initiated waiting on a thread with a QoS class is specified, investigate ways to avoid priority inversion. Okay, now what does this means? That means that compiler will just wait for this execution before doing anything else. Okay, so it might happen that there are some other tasks which are having more priority, and that can also get no stuck due to this task having more priority. Okay, so what we can do to avoid this error, one way is that when I'm creating this queue object, I can pass one quality of service here, and I can pass this with utility. So once you pass this, that means that if there is some other thread with high priority, the compiler will give the priority to that particular process, not to this. Okay, now let me run it again and see if this error is gone. And now you can see that there is no error. Okay, and if you see the output also, first it printed this because it is started here. Again, the asynchronous operation didn't wait for this completion, it came here and it printed here that I'm always doing what I want. Now first the Nilesh will come, so the moment the Nilesh came here, now you are making this value as 0. The value was 1, it became 0, and then it started all this operation. So ticket booking started for Nilesh, and then slip, and then all this print happened, that ticket is successful, and then signal, and then it again started executing the next process. Okay, and then the ticket booking started for what, for Ramesh. Okay, and then for Mahesh, and then for Sumesh. So in this case, if you see, for Nilesh and Ramesh it will be successful because we have available ticket as 5, and for Mahesh and Ramesh it is unsuccessful because we will not have any ticket at that point of time. Okay, so we can easily solve the issue of the race condition using this dispatch semaphore concept. Okay, now I just wanted to show you this value, that what if this value is more. Let's say that we have here 4, we want to execute 4 tasks, so I'll just keep the value as 4. That means that I don't want this thread to wait one process to complete before starting the next. Okay, and now you again will start getting some wrong behavior, because now all the process will start simultaneously. Now if you see that it printed that ticket is successful for all the object Ramesh, Nilesh, Mahesh and Sumesh. So because now there is no guarantee that this process will wait before executing the next, because for the first time when the semaphore wait gets called, so it will decrease from 4 to 3. So next time when the next process come, it is still positive. Okay, so until and unless it is positive, it will start no allowing the thread to execute itself. So that's the reason that you are getting the wrong answer in this case. So just keep in mind that how many process you want to execute for your scenario when you are dealing with it. Okay, so that's all for today's video regarding the dispatch semaphore. Hope now you have understood dispatch semaphore in this video and then dispatch barrier in my previous video. I'll continue this series with more videos on concurrency. So if you have not subscribed the channel, then do subscribe it. And if you have really liked my videos, then please comment, share your feedback. Thank you.